Good day, students. Uh, Hold the next lesson, next topic. Name the error integral. Error integral. The error integral. Error integral. Integral. This integral is denoted as phi capital of x, phi capital of x, which is the capital Greek letter phi, and it is defined by the following expression: 2 over square root of pi multiplied by integral from 0 to x of e to minus x squared dx. This integral isn't expressed by elementary functions, and then consider its properties and then construct its graph. First, make a following introduction. Find the value of improper integral from 0 to plus infinity of e to minus x squared dx, knowing that integral from minus infinity to plus infinity of e to minus x squared dx is square root of p. This formula is known formula from calculus. And we must the value of this integral. Use the known integral and separate this integral into two following integrals from minus infinity to 0 and plus from 0 to plus infinity. Integral from minus infinity to 0 of e to minus x squared dx, and plus integral from 0 to plus infinity of e to minus x squared dx, and it is square root of pi. Make the following change in the first integral. In this integral, and let x is minus t. Then dx is minus dt, and t is minus x. Then we must change the integral limits, because the given integral limits are the limits for the given for the variable x, and we must find the integral limits for the new variable t. If x is minus infinity, then let substitute minus infinity instead of x, and we will obtain that t will be plus infinity. And if x is 0, then t is also 0, because if substitute 0 instead of x, we will obtain that t will be 0. Then rewrite the first integral from plus infinity to 0 of e to minus t squared, and dx was be minus dt. We can take negative sign out of the integral symbol, and then we will obtain minus t squared is simply t squared. Then we will have integral from plus infinity to 0 of e raised to minus t squared dt. dt equals, then change the places of the integral limits, and you know that the in the changing the places of integral limits, the sign of the integral of the definite integral will be changed. Therefore, we will obtain plus integral from 0 to plus infinity of e to minus t squared dt, and also you know that the value of the definite integral doesn't depend on the integral variable. Therefore, we can change t by new variable x. Then it is 0 plus infinity of e raised to minus x squared dx. Then continue. Already was shown that this integral is equal to the integral from 0 to plus infinity of e raised to minus x squared dx. Substitute the new expression instead of this integral, and then we will obtain that integral from 0 to plus infinity of e to minus x squared dx plus integral from 0 to plus infinity of e raised to minus x squared dx is square root of pi. We have two the same integrals, and then it is equal to twice integral from 0 to plus infinity of e raised to minus x squared dx, and then we have that the integral itself will be equal to integral from minus to plus infinity of e to minus x squared dx is square root of pi in half. And it our result. Please rewrite. Already we obtained two results. The first result is following, that this integral from minus infinity to 0 is equal to the integral from 0 plus infinity of the same function, and each of these integrals is equal to the square root of pi in half. Then use the obtained results for the properties of the error integral. Now consider the properties of the error integral. The properties of the error integral. First property, find phi is the value of phi capital at 0. Phi of 0. Here we must substitute 0 instead of x in the definition of the error integral. 2 over square root of pi multiply integral from 0 to 0 of e to minus x squared dx. You know that if the limits of the definite integral are the same, then such an integral is equal to 0. Therefore, phi at 0 is 0. It means the graph of the error integral passes through the origin. Second point. We must prove that the error integral is the odd function. Odd function in array is tek funksiya, error function. Then phi of minus x equals 2 over square root of pi multiplied by 0 from 0 to minus x e raised to minus x squared dx. Here the integral variable can be any variable, and here we can change x, the integral variable x, by new variable t. For example, 2 over square root of pi multiply the integral from 0 to minus x e raised to minus t squared dt. Then make the following change. T is minus z. T minus z. Then dt is minus dz. Dt is minus dz. And here z is minus t. Now we must change also the integral limits. If t is 0, then z is also 0. And if t is minus x, then z is x, simply x. Z is x. Then continue. Use the obtained change equals 0 is changed, will change by 0, and minus x will change by x. 2 over square root of pi multiplied by integral from 0 to x e raised to minus. Must substitute minus z instead of t. Minus z squared, and dt is minus dz. Here minus z squared is simply z squared, and here we can take a negative sign out of the integral symbol. 2 over square root of pi multiplied by integral from 0 to x of e raised to minus z squared dz. And it is again, remember that the value of integral, I'm sorry, I forgot write minus in front of integral, and again remember that the value of the definite integral doesn't depend on the integral variable. We can change the value of the integral variable by t, for example, and it is phi of x. Therefore we can write equals minus phi of x. Thus phi of minus x equals minus phi of x, and it is the indication of the even of the odd function. It means for odd function, the graph of odd function is symmetric with respect to origin. Then continue. Then go to the next property, third property. Investigate investigate this function, the error integral, for increase decrease, for monotony. For this, find the derivative of this function, of the given function, phi capital prime of x equals 2 over square root of pi multiplied by integral from 0 to x of e to minus t squared dt prime. First say that 2 over square root of pi is a constant, is a coefficient, constant factor, and therefore we can take it out of the derivative sign, derivative symbol. Therefore, we will obtain 2 over square root of pi multiplied by integral from 0 to x of e to minus t squared dt prime. And here we have the definite integral with the variable upper limit, and derivative of such an integral is equal to the integrand at this variable upper limit, that is 2 over square root of pi multiplied by e to minus x squared. This coefficient is positive, and this value is also positive. Therefore, whole product is positive. It means the derivative is positive, and also it means that the function phi of x is increasing function. This function phi capital of x increases. Phi capital of x is increasing function. Increasing function. Then go to the fourth property. Then investigate the behavior of the function of error integral at infinity. First, investigate the behavior at plus infinity. Limit phi of x, limit phi capital of x, when x tends to plus infinity equals we can write phi of plus infinity, and we can substitute plus infinity instead of x in this integral. 2 over square root of pi multiplied by integral from 0 to plus infinity of e to minus dx squared dx. And already you know that this integral is pi in half equals 2 over square root of pi multiplied by square root of pi in half is equal to unit. That is limit when x tends to plus infinity of phi capital of x is unit. Which means the horizontal line y equals 1 is the horizontal asymptote. And finally, consider the last property, fifth property, and investigate behavior of the function phi of x at minus infinity. Limit of phi capital of x when x tends to minus infinity equals phi of minus infinity. Here we must substitute minus infinity instead of x in this integral. 2 over square root of pi multiply integral from 0 to minus infinity of e to minus t squared dt. Then we can change the places of the integral limits, and in this case the sign of integral will be changed, equals minus 2 over square root of pi multiply integral from minus infinity to 0 of e to minus t squared dt, equals this integral is square root of pi in half. Therefore we have minus 2 over square root of pi multiply square root of pi in half, and it is minus 1. And already you see that the at minus infinity the limit of the function of the error integral is minus 1. It means the line y equals minus 1 is also is the second or lower horizontal asymptote. And then construct the graph of the error integral. Finally, construct the graph of the error integral. Now verify the graph of the error integral. According to the first property, the value of this function at 0 is 0. That is, the graph will be passed through the origin. It is origin. Origin is in Azali is coordinate başlangıcı. Then according to the second property, this function is odd function. Really, the branches of this graph are symmetric with respect to origin. According to the third property, our function is increasing function. Really, our function increases. Then, according to the fourth property, at plus infinity, our function tends to unit, and the line y equals 1 is the horizontal asymptote. And according to the fifth last property, our function at means infinity tends to the minus 1. That is, the line y equals minus 1 is the horizontal, is another horizontal asymptote of this function. Now, go to the next topic, named the expression of the probability that the continuous random variable will with the normal distributive density will be will belong to the given interval with the help of the error integral. Please write this heading. Expression of probability that the continuous random variable will belong with the normal distributive density will belong to the given interval with respect to with the help of the error integral. It is the heading of our topic. Right, the formula of the probability of the continuous random variable. P of x belongs to the interval alpha beta is the integral from alpha to beta f of x dx. Then remember f of x here, f of x is the normal distributive density, and remember this formula. Integral from alpha to beta 1 over sigma multiplied by 2 pi multiplied by e raised to minus x minus a squared over 2 sigma squared dx equals. Then make the following change. Change. Let x minus a squared over 2 sigma squared is t squared. Therefore, x minus a over sigma square root of 2 is t. Then from here x is a plus sigma square root of t 2t, and dx is sigma square root of 2 dt. Also, we must change the integral limit, because the given integral limits alpha and beta are the integral limits for the variable x. But now we must define the integral limits for the new variable t. If x is alpha, x equals alpha, then substitute alpha instead of x. T is alpha minus a over sigma square root of t. And if x is beta, then we must substitute beta instead of x in this formula. and therefore we'll obtain beta minus a over sigma square root of 2, I'm sorry, t equals, must write 2, t equals beta minus a over sigma multiplied by square root of 2. Close the parentheses and then continue. Then use the last change in the given integral equals integral from we must alpha minus a over sigma square root of 2 instead of a here, alpha minus a over sigma square root of 2, and the upper limit will be beta minus a over sigma square root of t. 1 over sigma square root of 2 pi multiplied by e raised to minus t squared, and dx is sigma square root of 2 dt. Then we can simplify by sigma square root of 2 and take 1 over square root of pi out of the integral sign, integral symbol. 1 over square root of pi multiplied by integral from alpha minus a over sigma square root of 2 to beta minus a over sigma square root of 2 of e to minus t squared dt equals. Then continue. Then separate the last integral into integral from alpha minus a divided by sigma square root of 2 to 0, and plus integral from 0 to b minus a over sigma square root of 2. 1 over square root of pi integral from alpha minus a over sigma square root of 2 to 0 of minus 2 minus t squared dt, and plus integral from 0 to b minus a over sigma square root of 2 of e to minus t squared dt equals. Then here we can change the places of the integral limits in the first integral, and therefore this integral will change on sign. Then 1 over square root of pi of minus integral from 0 to alpha minus a to sigma square root of 2 e raised to minus t squared dt, plus integral from 0 to beta minus a over sigma square root of 2 of e to minus t squared dt equals. Then change the places of these integrals. These integrals 1 over square root of pi multiplied by integral from 0 to beta minus a over sigma square root of 2 of e to minus t squared dt, minus integral from 0 to alpha minus a over sigma square root of 2 of e raised to minus t squared dt. Then continue. Multiply and divide whole expression by 2 and introduce 2 over square root of pi into the brackets, equals 1 second, multiplied by 2 over square root of pi multiplied by integral from 0 to beta minus a over sigma square root of 2 of e raised to minus t squared dt, and minus 2 over square root of pi multiplied by integral from 0 to alpha minus a over sigma square root of 2 of e to minus t squared dt equals remember that this the value of error integral at this point, and it is the value of the error integral at this point. It is 1 second, phi of beta minus a over sigma square root of 2 minus phi capital of alpha minus a over sigma square root of 2, and finally we can say that our probability is equal to the this expression, that is p of that alpha is less than x is less than beta equals this expression. 1 second multiplied by phi of beta minus a over sigma square root of 2 minus phi of alpha minus a over sigma square root of 2. It is our obtained formula. Thank you for your attention. Thank you very much. Good luck. Goodbye, students.